Hi everyone. I will do this problem twice. I will do this problem 100% with the IC method and 100% with the vector method. And when I say 100%, I will not solve for any numbers, but I will show you the steps. I will use three colors. When I talk about the road AB, I will use the green. The road BED, I will use the blue. And the road CD, I will use the red. So I hope that helps. So you have to remember that what we know is the omega there. So let's solve for what we can do with the IC method. So we have the road A, B, okay? A is the fixed point. It's rotating about A. So this one will be the IC of the road AB, IC of the road AB, okay? So it's rotating on this line. So B will be in that direction. VB will be in that direction. We know the omega. If we do the IC, we know that VB equal omega time the distance AB. So we can find VB because we know omega and we know AB. So you will need to find the AB in that green triangle. But you know this distance, that is C plus D. You know that distance is A, so you know that distance. So that will be your first steps. Now, let's go on the road BD. So we have the road BD like this, okay? BD. We know the directions of VB, okay? Oops, this is point A. This is perpendicular to AB. We know that if we look at the road CD, let's draw the road CD on the bottom. So we have the three together. We have the road CD like this, CD, and we know that C, it's a fixed point. So C is the IC of the road CD. So the velocity, it will go to the right, turn in that direction, because everything turned counterclockwise in the positive directions. So we will have VD in that directions. So VD is VD. D belongs to the road BD and the road CD, that's the same. So we will have VD like this for the blue one too. Let's draw it in blue there. And this is the point C, and this is perpendicular to CD. So where is the IC of the road CD, BE? We have the E there, BED. That will be where AB and CD meet. So this one is the IC of the road B, okay, BD, BED. So if you want to solve for the omega of BD, we can use this formula, VB equal omega BD time, so let's call that F, like on my document, time BF, because F is the IC. So if you know this distance BF, we already know BD, that was this one, okay? So we know omega BD, not omega BD, sorry. Okay, forgot about what I said. That was omega AB. What I want to say is that we know VB, so we can find VB there. If we know BF, we can find omega BD. Omega BD or omega BED, because E is on this road, will be equal to the VB divided by the distance BF. So you need that distance. Now that we have this, if we want to find VE, VE equal omega BED time EF, this distance EF, that you all find. And we can find VD because they will be equal to omega BED times the distance FD. So you will need all that distance. Okay? Now that we have VD there, we can use VD in the last road, and we can write that VD equal omega CD, the last road, times the distance CD. Why CD? Because C is the IC. So you can find, you can use the VD there. You know the CD, so you can solve for omega CD equal VD divided by CD. Okay, so that's it for the IC method. It's just a question of where is the IC, so what is the distance from the IC to the point. Okay, I think it will be easier to solve everything with the IC on one side and everything on the vector method. So that's why I show you, I will make you two different videos for each of them. Try this. Try to see if you can find VB. After you find VB, you will find omega BED using that method. After that, you have omega BED, you can find VE, you can find VD, and after that, you have VD, you can find omega CD. That say, you need to find all those distance. You need to find the distance AB. You need to find, I'll put it in blue. You need to find the distance BF, FE, FD, and you need to find the last distance, the distance CD. All of those for the IC method. Hope that helps.